Hello, my dear students. Welcome to our science class. As you all know that we have already started with chapter 8 motion. Fine, and till now we have already completed 8.1 and 8.2. So today we will be starting with the next topic of the chapter, that is 8.3, rate of change of velocity, where we will be learning about acceleration, uniform and non-uniform acceleration, accelerated motion, and some numericals and also some textual questions will also be discussed. Okay, so let us start with rate of change of velocity. First is acceleration. The word is quite familiar to every one of us, right? When we do acceleration, specifically in our vehicles, what do we get? With a greater speed. हमारा जो vehicle होता है वो in a particular direction वो move होता है, isn't it? So this word is not new to us, the acceleration word I am talking about. Okay, so what is acceleration? It is a measure of the change in velocity of an object per unit time. We know the meaning of velocity. It is displacement in the given or per unit time, isn't it? So, when the velocity is changed of the particular object per unit time, that is described as acceleration. Mathematically, it is written as acceleration is equal to change in velocity upon time taken. Please remember this. This is very important. Okay. The SI unit of acceleration is meter per second square, and the quantity, it is a vector quantity because velocity is related to acceleration, right? And we know that velocity is also a vector quantity. So acceleration is also a vector quantity, that is it has both the magnitude as well as the direction. Am I clear? Just for an example, a car in straight line motion is said to have forward, that is positive acceleration, if it is speeding up, and rearward, that is negative acceleration, if it is slowing down. यानी कि एग्जाम्पल में क्या बोल रहे हैं, अगर एक कार मूव हो रही है इन अ पर्टिकुलर डायरेक्शन और आई कैन से इन अ स्ट्रेट लाइन, सो इन दैट केस if it is moving forward, अगर वो आगे जा रही है, that means it is a positive acceleration, right? But when we apply brakes, जब हम ब्रेक अप्लाई करेंगे तो वो धीरे धीरे करके वो अपना मोशन स्लो डाउन करेगा, right? And one time will come when your car will stop. So when we had applied brake, that time whatever acceleration is experienced by us, that is called as the negative acceleration. Am I clear? So acceleration can be positive as well as negative. Okay, so now let us discuss about uniform and non-uniform acceleration. A body has uniform acceleration if it travels in a straight line and its velocity increases by equal amount in equal intervals of time. For example, freely falling bodies, motion of ball rolling down the inclined plane, etc. यानी कि जब भी हम किसी भी चीज़ को ऊपर से नीचे फेंकते हैं, सो उसकी स्पीड तो बढ़ेगी बढ़ेगी, एक्सेलरेशन होगा, यस. Along with the acceleration, the velocity will also gets increased. Am I clear? Direction, in a particular direction वो चीज़ नीचे गिर रही, राइट? इफ़ वी टॉक अबाउट फ्रीली फॉलिंग बॉडीज, वो ऊपर से नीचे फेंक रहे हैं, राइट? सो नीचे की ओर उसकी वेलोसिटी बढ़ रही है, स्पीड बढ़ रही है, isn't it? So everything is increased. Fine. So this is known as uniform acceleration. And if we talk about non-uniform acceleration, it will be exactly opposite to that. Okay. So what is a non-uniform acceleration? A body has non-uniform acceleration if its velocity increases or decreases by unequal amount in equal intervals of time. Am I clear? यानी कि नॉन यूनिफॉर्म एक्सेलरेशन, द नेम इटसेल्फ टेल्स कि एक्सेलरेशन नॉन यूनिफॉर्म मैनर में जा रहा है, मीन्स उसकी वेलोसिटी है आइदर इट इज इंक्रीजिंग और इट इज डिक्रीजिंग in the equal intervals of time. Am I clear? If we talk about this freely falling bodies only, अगर मैं ऊपर से 10th फ्लोर से ग्राउंड फ्लोर तक कोई चीज़ फेंकती हूँ, सो दैट इज गोइंग टू बी अवर यूनिफॉर्म एक्सेलरेशन. बट अगर इन बिटवीन या फिर थर्ड फ्लोर पे, फिफ्थ फ्लोर पे, सेवेंथ फ्लोर पे कुछ ऐसे ऑब्स्टेकल्स मैंने रखे हैं कि जिसके साथ वो फ्रीली फॉलिंग बॉडी वो ऑब्स्टेकल के साथ कुछ उसका कोलाइजन होगा. So during that time, what will happen? The direction will get changed. That is, velocity will get changed, isn't it? So that can be considered as the example of non-uniform acceleration. Hope both the terms are quite familiar to you now. Hope you have understood it very well. Okay, you have to remember it, of course. The graph which represents the uniform as well as the non-uniform acceleration. Okay, just have a look at the first graph, this graph. See, with the constant increase, I'm talking about the first graph here. With the constant increase in the time, the velocity is also increasing here. So here we are getting a straight line. Okay, now here if we will see, with the increase in time the velocity is constant, right? So that is known as the constant deceleration, which is also known as retardation. Whereas here हमें क्या दिखता है? नॉन यूनिफॉर्म एक्सेलरेशन एंड नॉन यूनिफॉर्म डेसिलरेशन. जब भी ऐसे कर्व्ड लाइन कोई भी आएगी in any of the graph, that will show us the non-uniformity, whether it is acceleration or whether it is motion, right? So this is a small technique to remember whether it is a uniform motion or acceleration, whatever, and non-uniform acceleration or motion. Okay, so if the velocity of an object changes from an initial value u to the final value v, that is starting from the beginning and at the end, when the any object starts moving, that time its velocity is almost zero, and whenever it reaches at the particular point, or I can say the final destination, that time its velocity will be different, right? So if it moves in time t, the acceleration a is given by this formula, and this is very very important. Acceleration a is equal to final velocity minus initial velocity upon t. Okay, and this kind of motion is known as accelerated motion. If acceleration is in the direction of velocity, then it is a positive acceleration. जैसे जो freely falling body ऊपर से नीचे गिरी, right? ऊपर से नीचे एक ही डायरेक्शन में मूव किया उसने, सो दैट इज नोन एज पॉजिटिव एक्सेलरेशन. बट इफ इट इज इन द डायरेक्शन अपोजिट टू द डायरेक्शन ऑफ वेलोसिटी, देन इट इज गोइंग टू बी नेगेटिव. यानी जब एक्सेलरेशन बंद हो जाएगा, इन सिंपल वर्ड्स, जब हम कार चलाते हैं, राइट, जब हम एक्सेलरेट करना बंद कर दें या फिर इफ़ वी अप्लाई ब्रेक्स, सो इन दैट केस क्या होगा? वो एक्सेलरेशन उसका नेगेटिव डायरेक्शन में जाएगा. मीन्स गाड़ी आगे बढ़ रही है बट एक्सेलरेशन उसका अपोजिट डायरेक्शन में जा रहा है. ब्रेक अप्लाई कर रहे हो ना, ब्रेक अप्लाई कर रहे हो ना, राइट? सो इन दैट केस क्या होगा? भले आपकी गाड़ी आगे बढ़ रही है बट इट विल बी इन द अपोजिट डायरेक्शन. That is, it is considered as the negative acceleration, and this negative acceleration is termed as retardation. This is very very important. Am I clear with this? Okay, next we have, since acceleration is a vector quantity, as we have discussed, it has a direction associated with it, and the direction of the acceleration vector depends on two things: whether the object is speeding up or slowing down, and whether the object is moving in the positive or negative direction. You have to remember these 2 points as well. Okay, so acceleration की direction कौन describe करता है? Whether the object is in motion or not, that is whether it is speeding up or not. And the second, whether it is going in the forward direction or backward direction. वो आगे जा रहा है कि पीछे आ रहा है? Am I clear? So these two things will describe the direction of acceleration. Okay, the general principle for determining the acceleration is, if an object is slowing down, अगर कोई ऑब्जेक्ट स्लो डाउन हो रहा है means it is opposite to the direction of its motion. Of course, I am giving you once again the same example of applying the brakes. जब भी आप स्कूटर चलाते हो, आप ब्रेक लगा रहे हो, यानी आप उसकी एक्सेलरेशन को आप स्टॉप कर रहे हो. यू आर प्रिवेंटिंग योर मोपेड टू मूव अहेड. Am I clear with this? So this is considered as the negative acceleration, which is also known as retardation or deceleration. Am I clear? Just try to understand the concept of velocity and acceleration, where you can see that red object is moving. So when the object is slowing down, as I have discussed right now only, the direction of acceleration will be opposite. देखो देखो अपोजिट हो गया ना डायरेक्शन. वापस देखो, स्लोप से नीचे आ रहा है. जब ऑब्जेक्ट स्लोप से नीचे आ रहा है, दैट टाइम बोथ द एक्सेलरेशन एंड वेलोसिटी दे आर इन द सेम डायरेक्शन. अभी स्लो डाउन हो गया तो एक्सेलरेशन अपोजिट हो गया. इजंट इट? इज दिस क्लियर नाउ? या. Now here I have tried to show you the points of differences between acceleration and deceleration, that is retardation. This is one of the important differences. Okay, it is change in velocity per unit time, it is always positive, whereas the deceleration, it is the change in velocity per unit time but it is always negative. Retardation हो रहा है, opposite to the direction of velocity. Okay, second point, in this case the velocity keeps increasing. स्पीड बढ़ रही है, एक्सेलरेशन हो रहा है, वेलोसिटी बढ़ रही है, राइट. वेयरएज हियर इन केस ऑफ डेसिलरेशन द वेलोसिटी विल ऑलवेज बी इन द डिक्रीजिंग कंडीशन. ओके, हियर यू मीन्स what is u? Initial velocity. Initial velocity is less than final velocity. U is equal to 0. That is, जब हम स्टार्ट करते हैं दैट टाइम हमारी वेलोसिटी ज़ीरो होती है. ओके, जब घर से आप स्टार्ट करते हो या फिर एनी स्टार्टिंग पॉइंट, द वेलोसिटी, इनिशियल वेलोसिटी विल बी ज़ीरो. ओके, whereas in case of deceleration the final velocity is less than the initial velocity. यानी कि जब मैंने स्टार्ट किया था, मे बी दैट टाइम माई वेलोसिटी वॉज लाइक almost 60 किलोमीटर पर आवर. Okay, or maybe 60 kilometer per hour, and my final velocity, maybe when I stopped, that time my final velocity was around about 20 or 10 kilometer per hour. Okay, so that is considered as deceleration. Okay, so now this flow chart you can note down in your textbook or notebook, wherever you want to, right. This may be helpful to you. Here from this flow chart you can note down both the uniform and non-uniform acceleration definition. The definition of acceleration is also given. Along with that, that is the SI unit is also given, and the formula. Okay, so this is just a small helping hand from my side. If you want, if you don't want, that is completely your choice. Fine. Now let us discuss about example 8.4. Starting from the stationary position means the object is at the rest. Okay, Rahul pedals his bicycle to attain a velocity of 6 meter in 30 seconds. Then he applies brakes such that the velocity of the bicycle comes down to 4 meter per second in the next 5 seconds. So calculate the acceleration of the bicycle in both the cases. Now if you notice, I have done underlining of few terms which are seen in the example. So you also please do the practice of the same. Whatever terms or whatever numbers are given along with the formulas or the units, you have to note it down. Okay, and what is the final calculation of acceleration only, right. So यहाँ पे दो cases दिए हैं. Starting from the stationary position means initial velocity 0 होगी, final velocity कितनी आई? In 30 seconds. Am I clear? So let's see how the calculation has to be done. For case 1, I am talking about this first case when Rahul started. So that time the initial velocity u was 0 meter per second and final velocity was 6 meter per second. Yes. in time t. And acceleration, we know the formula. Acceleration is final velocity minus initial velocity upon time, isn't it? So on substituting the value for case 1, we will be getting acceleration as 0.2 meter per second square. As I said, here I have forgotten to write the answer in the box, but it is necessary for you to write it down in the box, and do not forget to write the units. Okay. For case 2, that is second case, here 4 meter per second in the next 5 seconds. So initial velocity means where he stopped in the first case, that will be his initial velocity for the second case, isn't it? Because he is applying brake here. He is applying brakes here. So 6 मीटर पर सेकेंड जो जब वहाँ पे वो रुका था, जहाँ से उसने स्टार्ट किया ब्रेक लगाना, वो उसकी इनिशियल वेलोसिटी होगी. सो इनिशियल वेलोसिटी फॉर केस 2 विल बी 6 मीटर पर सेकेंड एंड फाइनल वेलोसिटी, क्योंकि उसने ब्रेक लगाई है, देखिए आप इधर उसने यहाँ पे ब्रेक लगाई है, इसकी वजह से उसकी वेलोसिटी, फाइनल वेलोसिटी कम हो गई एज कंपेयर टू द इनिशियल वेलोसिटी. नाउ डिड यू अंडरस्टैंड, राइट? So final velocity 4 meter per second. Or substituting the value in the formula for second case, we have got negative acceleration. Negative acceleration को क्या बोलते हैं हम? Yes, it is deceleration और retardation. बराबर? समझ में आई बात? And as you know, you have to write the answer. The acceleration of the bicycle in the first case is positive 0.2 meter per second square, and in the second case it is negative 0.4 meter per second square. Am I clear? Let us move further. Right. Question 1, which is given on page number 103, you have to note down the definition of uniform and non-uniform acceleration. We have already discussed about it, so I think I need not to repeat it. Please go through the explanation seen on the screen. Fine, and you have to learn both the definitions. Next, a bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. Find the acceleration of the bus. Speed decrease हो रही है, कैसे decrease होगी? Of course, बस वाले ने brakes apply की होगी, right? So let us note down whatever is given. Now if you will notice in the question, it is given as kilometer per hour. So we have to convert it into meter per second first of all, isn't it? Hope you recall what conversion I have taught you in the previous video. If you have not gone through it, you can have a look at the description box. I have given you the link of the previous video. Okay, so let us note down the terms which are given. Initial velocity, we have to convert it into meter per second. Fine. Final velocity will be also converted the same way. The time taken is 5 seconds and acceleration has to be found. Use the formula, substitute the value and find the final answer. Fine. Now because here the brake is applied, the brakes are applied by the bus driver. So of course it is going to be the negative acceleration, that is retardation. So final answer will obviously in negative. Am I clear? So the answer will be negative 1.112 meter per second square. Okay, next. So let us start with the third one. Now here I have not underlined anything because I want you people to do it on your own. Okay, so what you will underline first? The speed which is given in 40 km per hour. Then the time is given 10 minutes. And what is the question? What has to be found? Yes, acceleration. So let us read the question. A train starting from a railway station and moving with uniform acceleration attains a speed of 40 km per hour in 10 minutes. So find its acceleration. So we know that we have to do some conversion because the speed is given in 40 km per hour and time is given in minutes, right? So let's have a look. Fine. So initial velocity, that is the train has started. Initial velocity is 0 km per hour. Yes, you have to note it down here as 0 meter per second, because if we multiply anything with 0, we get 0 only. Am I clear? So in initial velocity, you have to note it down 0 km per hour is equal to 0 meter per second. Final velocity 40 km per hour has to be converted into meter per second, right? And minutes, time which is given in minutes, it has to be converted into seconds. Am I clear? Now use the formula and substitute the value. Final velocity will be 0.0185 meter per second square. It is positive. Why? Because it is uniform acceleration, and we know in uniform acceleration the velocity increases. Am I clear? So hopefully you have clearly understood what is the meaning of acceleration, uniform, non-uniform acceleration, how to use the formula, and the most important part, the differences between acceleration and deceleration or retardation. Am I clear? So stay tuned for the next video. Thank you.